Welcome back to Research Methods Basics, Confidence Intervals. This is the second video. So if you haven't watched the first, I suggest going back and getting at least a little bit of background on what we've done, which is here on our left. We left off with the first video and said the next step is to create an interval estimate. We already have our point estimate, but now we need to figure out the sample standard deviation. I know it's been a little while since we have actually created a standard deviation by hand, so I've gone ahead and given you the equation. The sample standard deviation is the sum of all x minus x bar squared divided by n minus 1. And we take the square root. So let's go ahead and set up a table that makes it a little bit easier to pull this together. What I've gone ahead and done is flipped the table that we had been working with so that I could put all of the x values into one column. And I went ahead and I put them into one column in ascending, or an order that goes from least to greatest, just to make the next steps easier. And now I'm just going to fill in this small table with the other values that I need. So I'll start here. There's my starting point. It's with that 2. Now, the first thing I want to do, I'm just going to try to remember what we've practiced, is I'm going to do the entire x minus x bar column. So for the 2's, I will have 2 minus 9.5, and that will equal negative 7.5. And then I'll do the same for the 3's. 3 minus 9.5 equals negative 6.5. You get it. I'll give you a chance to go through the rest of the table and fill in the column x minus x bar. Make sure to click pause while you're working on completing the x minus x bar column. Through, and you have completed the x minus x bar column for every single x, you're going to work on the x minus x bar squared column. So essentially, what you're going to do is you're going to take each x minus x bar squared and multiply it by itself. That'll give us x minus x bar squared. So, for example, this 2 value will be negative 7.5 times negative 7.5. Go ahead and click pause as you work through this column. It takes a lot of work to do this by hand, right? I bet you can't wait to get to SPSS. Now, once you have the entire table filled out with all of your x minus x bar values and all of your x minus x bar squared values, what I'd like you to do is go ahead and take the sum of all x minus x bar. So add up that entire column, and then add up all of the x minus x bar squared. Out and pause yet. Let me explain. The sum of all x minus x bar should equal to 0. But this is one instance where if you used our x bar equal to 9.5, then we have an issue of rounding error. If we go ahead and go out about, let's see, 4 or 5 decimal places when we were calculating x bar, then it's more accurately 9.54161. So it could be that your sum, if you had used the rounded up version, 9.5, the sum could equal 2. If you go back through and you use the more accurate mean, then the sum of all x minus x bar is equal to 0. I went ahead and I used the more accurate mean when I was calculating x minus x bar squared. So my sum of all x minus x bar squared is 1307.92. So let's go ahead and plug in these values into the sample standard deviation equation. So sample standard deviation is equal to the square root of sum of all x minus x bar squared divided by n minus 1. And we know that n is 48, so we'll divide that by 47. Go ahead and hit pause, work this math, and let's see if we get the same sample standard deviation. Okay, after completing that math, I have a sample standard deviation of 5.28. Finally, to the point where we can determine our margin of error. Okay. The formula for determining the margin of error, or the equation, we'll let E equal the error. And since we have a sample size greater than 30, and as a data analyst for this VIP program, I think the stakeholders would be pretty happy if I could say, well, let's see. I think I want to say that I am 95% confident. Yeah, I want to say that I'm 95% confident that whatever value I give them regarding the number of folks who complete services per month is representative of the larger VIP population. So error is equal to, in this case, we can use a z critical value. We're going to let our sample standard deviation represent the population standard deviation. Why? Central limit theorem. And the square root of n. Okay, let's plug in the values that we know to determine the margin of error here. All right, so at a 95% confidence interval, well, the z critical value at 0.0 or 0.95 is equal to 1.96. If you're wondering where I got the z critical value, you can either find it on the Z table that I have uploaded into your course, or it's something that we've memorized because at least in criminology, criminal justice, we're usually dealing with large samples, over 30, and the Z critical values don't change when you have a random representative sample that's greater than 30. So a Z critical value, if I want to say I'm 95% confident, I'm going to use the 1.96. So our error is equal to 1.96 times my sample standard error, 5.28, divided by the square root of our sample size, which is 48. So the square root of 48, our sample size, is 6.93. Once we complete this math, we will see a margin of error about 1.49. I think I'm going to go ahead and just round it up to make it a little bit easier on us. And I'll say our margin of error is 1.5. Okay, this is kind of cool now. Now we get to do a couple of things really fast, finally, right? Okay, so if we know our margin of error is 1.5, and we know that our sample mean is very roughly, right, 9.5, then I want to create an interval. The point estimate, our sample mean, is 9.5. I can add 1.5, our margin of error, to this point estimate. This number is going to be the top of our interval, and I can subtract 1.5 to get the lower estimate. Okay. And now, here's what I can say about this interval. I am 95% confident that on average, VIP participants, there are between 8 and 11 VIP participants who complete services each month. I can be 95% confident that between 8 and 11 VIP participants complete services each month. Pretty cool, right? That last statement means we have gone from using our intern's data, our sample of data, all the way to creating a confidence interval for a population mean. What a productive 15 minutes. Yeah, right. See you in the next video.